Let's talk about data classes. Since Python 3.7, we have data classes. When to use them? Here's a Stack Overflow answer. If you're mainly writing the classes to hold state and not that much logic or behavior, then data classes are a good fit. And let me demo what a regular class definition looks like and where we can save a lot of boilerplate with data classes. So class A, we typically have a constructor. Assign the attributes. Give a string representation. Give an object representation. And to not hard code the class, I can also get the class name like this. Let's test this out. I need, of course, to provide the arguments of the constructor. And we have a string representation and a wrapper or object representation, which you can test by pass it into the eval built-in function, which works, right? This is some boilerplate, and if you do this over and over again for data-driven classes, we might as well use a data class. And the only thing we need to do is define the attributes. So name is going to be string, and we get this typing out of the box, which is a really nice benefit. And then we can ditch all this. And right out of the box, we get this behavior for free. And of course the stir as well. So really nice. So let's look at some other things we can do. If we want to do some processing in the constructor, for example, let's say we want to title case the name, we can define a post init and say self name is self name title. And now the name effectively gets title cased upon initialization, upon instantiation, when the constructor is called internally. So that's cool. The other thing, if I make a second instance, what's not yet supported is comparison, right? So it only comes with an equality dunder method included. And that's because if we call help on data class, if you look at the signature of the decorator, the init is true, so we get a constructor. The wrapper is true, so we get a wrapper. EQ is true, because so we get that equality dunder. But order is false. So if we set order to true, now this works. So A is greater than B. Sorry, A is not greater than B, but A is less than B. And you might be wondering, well, how is that evaluated? And that's literally going through the order of the attributes. So I comes before O, and that's why A is smaller than B. So if we would give this another name that comes after Tony, now A is actually less than B. If we want to do that by age, we have two options. We can swap the order, but then of course we also need to update the instantiation. And of course I need to rerun this cell. Then A indeed is smaller than B. If we reverse that, then it is false. So, or you do that, or you can still, of course, write your own less than, greater than dunders. Let me put it back how it was. The final thing to demo is mutability. So I'm just going to work with one instance for now. And nothing stops us from overriding this attribute. So if you want to have an immutable data class, you can give it frozen equals true. And actually that's interesting, then I cannot even do the post in it because I'm mutating the object. So then I cannot effectively do this operation. Nor can I set the attribute after instantiating it. So yeah, that's a quick run through of the main features of data classes. Very nice, save a lot of code. Again, it's mostly for classes that are geared towards storing state. If you add a lot of logic, I'm not sure if I would use a data class. But yeah, this is really cool and I hope this is helpful.